Hello everyone, myself Professor Tushar Gujrathi from S&D College of Engineering, Yeola, Mechanical Department. Today we'll study experiment number 7 of mechatronics subject, and the experiment name is liquid level measurement using capacitive transducer. So this is the name of the experiment. So now what is objective of the experiment? The objective is to measure the liquid level in the tank using capacitive transducer. So in this case we are going to study capacitive transducer and we are going to measure the liquid level in the tank. Okay, so like this is the objective. So now what should be the outcome of the experiment? The students must be able to understand the method to measure the liquid level in the tank using capacitive transducer. So student must be able to understand how the liquid level gets measured. Okay, so this is the outcome of the experiment. Now this is the capacitive transducer. Okay, so first question is there, what is capacitive transducer? So do you know what is capacitor? So capacitor made up of two plates, okay, and the plates are having charges upon them, positive and negative charges, as well as in between those plates what is there, dielectric medium is present. So this is the construction of capacitor. So now in this case also you see there are two plates are shown, okay, one is movable plate and one is fixed plate, and in between them the green colored portion shows dielectric medium. So the medium depends on the permeability of that medium depends upon different materials like air, water. Okay, so like this, if there are different mediums are there, then dielectric constant is also different, and we get output on the electrodes taken out. Okay, there we will get output. So here in the box what is shown, formula is shown, formula for capacitance. So what is the formula? C is equal to epsilon 0 into epsilon r into capital A divided by D, capital D. Okay, so here what is C? C is capacitance value. C is called as capacitance value. What is epsilon 0? It is permittivity of free space. Permittivity of free space. And now what is epsilon r? Epsilon r is relative permittivity. It is called as relative permittivity. Okay. Now A, capital A is area of the plates. So there are two plates. So the cross sectional area of the plate is called as capital A, and D is called as distance between the plates. So D is nothing but distance between the plates. Okay. So all this value depends upon each other. Okay. So suppose here area is directly proportional to the capacitance. Okay. So area is directly proportional to capacitance, and distance between plates is inversely proportional to capacitance. Okay, so if distance between plates is decreased, then capacitance will increased. So there is inversely proportional. So if you change distance between both the plates, what will happen? The capacitance will get changed. Similarly, if you change the medium between the plates, dielectric medium, if you change, what will happen? The relative permittivity of the medium will change and will get capacitance value different. Okay, so like this we have relations between permittivity, area of plates, and distance between plates. So out of this any parameter changes, then capacitance changes, and then this capacitance is measured as the output. Okay, now this is one circuit diagram is shown over here. So the capacitance sensor is placed in the tank. Okay, so tank may be filled with some liquid. So pump is provided to fill the tank. Okay, so you can see there are two plates of capacitors you can see in the tank. So that is sensor. So sensor can sense minimum liquid level is shown in the diagram. So that is minimum liquid level, and the maximum liquid level that can sensor show, that is also shown. So sensor tips, that is positive and negative terminals, are taken out and they are connected to control circuit, and control circuit is connected to LCD panel for showing us reading. Like this reading can be shown. Okay. Now What is the procedure to conduct the experiment? So what we have to do, we have to first of all fill the measuring tank with water up to 500 mm. So first step is to fill the measuring tank with water up to 500 mm. Second option, switch on the main supply. Then we have to switch on the main supply. Hence level transmitter and level indicator will be on. So we have to make level indicator on. Next, decrease the water level with the help of drain tap and note the readings of corresponding digital level indicator and current output across the test points. Okay, what we have to do in third step, we have to start the tap, drain tap. Okay, so water will get reduced in the tank and we have to note down the readings. And last point, do not remove any wiring connections of the level transmitter, handle it carefully. So we have to keep level transmitter connections and we have to handle it carefully. This is the lever measurement setup. Okay, so this is the lever measurement setup available in our lab. So here you see, this is the drain tap, it's shown over here. This is the level indicator, and from top side we are going to put the water inside the tank. So this is the tank. Okay, the scale is provided on the tank, and inside that the capacitor transducer is placed. That white colored portion indicates as capacitor transducer. So we have to change the water level in the tank and we have to note down the readings in the indicator. Okay, now this is the observation table for the experiment. So what is first? Level in mm, that is mechanical scale. So manually with the mechanical scale we have to note down the levels. Okay, and digitally we have to note down the readings in the second column, level on digital indicator. So this we have to note down in second table, and at the end current output in milliampere, this also we have to note down. So current output in milliampere, this we can measure at the output terminal. So this we have to measure. Okay, so like this is the observation table. So here I have shown you some sample readings. So starting from 500 mm level, so digital indicator indicates also 500. Now second reading 450 mm level, digital indicator indicates 452 mm. Third 400 reading is there, but digital indicator indicates 404. So there is manual change in the reading. There is little bit change in the readings is observed. Okay. And last current output in milliampere. So last column indicates current output in milliampere, so that is measured in output points. So its value is 20, 18.45, 16.91. Okay, so like this we get output, current output in milliampere. So like this observation table is formed. Now we have to plot the graph. How will you plot the graph? Liquid level in mm versus output current in milliampere. So this you have to plot. So on x-axis you should take liquid level. Okay, and here you see ampere, that is current in milliampere. Okay, this you have to take. Okay, so now after conducting this experiment, what should be your conclusion? From observation table and graph, it is found that the capacitive transducer indicates the readings of actual level in the tank. Okay, so we are able to measure the actual level in the tank with the help of capacitive transducer. So this is the conclusion of our experiment. Okay, so thank you so much all of you for watching this video.